Hello, and welcome to this video where we're going to go through how to answer questions on electricity. What I suggest you do is download the booklet, the link is in the description below, and have a go at those questions. Once you're confident, come back here, we'll go through those questions and you can see how well you've done. So let's get started. Okay, so in question 1, you have to redraw the circuit in the correct way. There's a few things to look out for, and it's really common in each of these questions. Number 1, the cells here. You can see that 2 positive sides have been put together. It's a really common error that they put in exams to try and catch people out. So when we're drawing our circuit, our cells should look like this. The second common error are the voltmeter and ammeter, which are the wrong way round. The voltmeter here should be connected in parallel, where the ammeter is, and the ammeter should be connected in series. So let's swap those around. And there we go. So our 2 marks, 1 mark for the cells correctly drawn, and 1 mark for the ammeter and the voltmeter connected correctly. In this second question here, we need to take the reading on the voltmeter. You can see that the arrow is clearly pointing to not the first, but the second indentation. It's really common for people to think that this is 6.2 and move on, but that's not correct. We've only got 5 dashes leading up to the 7, so every dash represents 0.2. So therefore it's 6, 6.2 and 6.4. So just be really careful to make sure that you're not missing out on those simple marks. In the third part of the question, the student has set up a circuit to investigate how resistance affects the brightness of a lamp. The figure here shows the circuit that was set up. The student increases the resistance of the variable resistor and you need to explain what effect this has on the brightness of the lamp. Well, because you've increased the resistance, therefore the current is going to decrease. Decreasing the current will mean that the bulb becomes dimmer. Your 2 marks come from this point and this point here. Equation questions are really common in physics and you need to know your equations. For this equation, the equation that links current, potential difference and resistance is potential difference equals current multiplied by resistance. Commonly in these questions, when you get an equation question, the question afterwards is going to rely on you using that equation. In this equation, it tells us that the potential difference across the lamp is 3.3 volts and the current is 0.15 amps. And we need to calculate the resistance of the lamp in the student's experiment. So we're going to use the equation above. The potential difference in voltage is 3.3 equals the current, which is 0.15 amps, multiplied by resistance, which is what we're looking for, I'm going to call R. To rearrange this equation, we want to bring the 0.15 over to this side. So we're going to do the opposite. So instead of multiplying by 0.15, we'll do 3.3 divided by 0.15 to give us our resistance. Working that out on a calculator gives us 22 ohms. Okay, our next question again is still about circuits. The figure here shows a circuit diagram that contains 2 identical lamps arranged in parallel. The reading on the ammeter is 186 milliamps. Again, it's something to watch out for. We've got a non-standard unit. A milliamp is 1,000th of an amp. So to convert milliamps into amps, we want to divide by 1,000, which gives us 0.186 amps. Which statement about the current through the lamp is true? Tick 1 box. If we know that the current through here is 0.16 amps, the current will be split evenly because the bulbs are identical between the 2. So if we want to know the current through either P or Q, we take our current, which is 0.186 amps, and we divide it by 2. If we do that, we get 0.093 amps. So therefore the current through both lamp P and lamp Q is 0.093 amps. In our second question, one of the lamps breaks and is not replaced. Which statement about the current in the other lamp is true? Well, the current in this case would be the same as if the lamp was on its individual, so therefore the current will still be the same as the previous question. So previously it was 0.93 amps, it will stay at 0.093 amps. So this one here. Finally, we need to sketch a current potential difference graph for a filament lamp. Again, we need to know those I mentioned in the specification. So if you're drawing for a filament lamp, it would start at the origin and the gradient would slowly decrease. So it would look like this. When drawing these, it's important to make sure that you don't bring the graph back down at the end. Okay, so nice levelling off. Okay, question 3. Most electrical appliances are connected to the mains electricity using 3 core cables. What's the approximate value of the potential difference of the UK mains electricity supply? Circle the correct answer. Again, this is one of those simple learn your answer questions. 230 volts. The figure below shows a 3 core cable. Fill in the labels to complete the diagram. They've given us the live, and it's quite common in exams that they're not colour diagrams, so we need to use the information we've got here. We can see the stripes on this one indicating that this would be the green and yellow striped cable, so therefore this must be the earth. And the only cable we've got left over is the neutral, which would be this one, the blue wire. In the UK, the 3 wires in a 3 core cable are always the same colours. Why are the wires always the same colours? We're looking through our answers here. Each wire is made by a different company. It's pretty nonsensical, so we can rule that one out. They're cheaper to manufacture. Well, that might be the case, but again, not really relevant here. The reason is it's easy to identify each wire, so you don't make a mistake when working with them. Touching the live wire is dangerous. Use answers from the box to complete the sentences. Touching the live wire causes a large potential difference to exist across the body. This causes a current through the body, which results in an electric shock. Question part 5. What is the approximate frequency of the UK mains electricity supply? Tick one answer. Again, use our knowledge builders. You can find them on our website to learn these answers. The frequency of the UK electricity supply is 50 Hz. This figure shows how power stations transfer electrical power to consumers using the national grid. It tells us the power station generates electricity at a voltage of 25 kilovolts. Transformer A increases the voltage by a factor of 16. What's the voltage output of Transformer A? Again, they've given us non-standard units, which is why I highlighted it here. But if we look at our answer, it's also in non-standard units, so we don't need to worry about this. Increasing the voltage by a factor of 16, if it starts at 25, to increase by a factor of 16, you simply multiply by 16. 25 multiplied by 16 gives us 400. Our units are still in kilovolts. So our answer for the output voltage is 400 kilovolts. This is a step-up transformer. Why is the voltage increased by transformer A? It's a nice simple question as it gives us the choice of answers. This is a really common 2 or 3 mark question at the end of these exams. The reason that the voltage is increased by transformer A is to reduce the energy loss due to heating. Okay, the question's getting a little bit longer now. Here, 2 students investigated how the resistance of the thermostat varies with the temperature. The student places the thermostat in a beaker of water and measured the resistance of the thermostat for 4 different temperatures, which you can see here, 20, 30, 40 and 50. They repeat the experiment 3 times, 1, 2, 3, and they've calculated a mean of each of those results. In this first question here, we need to calculate the missing values. So the first one is simply the mean. So we're going to sum the 3 numbers up. And divide by 3 to get us our mean. If we sum those up, we get 2,403, still divided by 3, gives us 801. This question is a little more tricky, because in this one they haven't given us the third value, we have to work it out ourselves. So in this case we know that 766 plus 754 plus the missing value, which I'll call x for the moment, divided by 3 equals 758. Now we can just simply rearrange our equation, so we're going to bring the multiply by 3 over here, and we'll work out the 766 plus 754, so we get 1,520 plus x equals 2,274. We now need to bring the plus 1520 over to the other side by minusing it. So we'll do 2274 minus 1520, which will give us 754, which is our missing value here. Describe the pattern shown by these results. Now this is a 2-mark question, so it's not enough just to make a simple statement about which one goes up and which one goes down. When doing these questions, it's really important that you always refer to the values in the headings as well. So I would be saying that as the temperature increases, and again, I'm just writing it in shorthand, but make sure you write it out fully. As the temperature increases, we can see that the resistance decreases. Now that's only enough to get us 1 mark. We want to be looking for something a little bit further. If we notice here, you can see the resistance decreases by a lot here. It's nearly, just over 1,000. It then decreases by about 200 and then by about 50. So we can see that the decrease is very rapid at the start and then gets less. So it decreases rapidly at the start, which are the low temperatures, and less at the high temperatures. Suggest one way that the experiment can be improved. Well, if we're looking for a pattern, we could be looking at what happens in between here. So 25, 35 and 45. So one suggestion would be to use smaller intervals, such as 25, 35 and 45 degrees Celsius. Always remember to give the examples to show that you know what you're talking about. Finally, a maths question. At 10 degrees Celsius, the thermostat had a resistance of 2,400 ohms. The thermostat has a power rating of 68 times 10 to the minus 3 watts. Calculate the maximum current in this thermostat at 10 degrees. Give your answer to 3 significant figures. For this, we're going to be using the equation power equals current squared multiplied by resistance. A good tip is to always include the calculation to include the formula to make sure you're picking up those marks. So the power is 68 times 10 to the minus 3, the number that we've got from here, equals the current squared. We don't know what that is, so I'm going to leave current as C squared, multiplied by the resistance, which was 2,400. Again, we want to rearrange this by bringing the 2,400 over here. So we're going to get 68 times 10 to the minus 3 divided by 2,400 equals C squared. To get rid of the squared, I'm going to square root this side to find out C, and we get 0.0053229. Now it says in the question to give our answer to 3 significant figures. So our first significant figure starts off here, and we don't include any zeros before our first significant figure, so 0.00. So 5, 3, and then this is our third significant figure. So we're going to look at the one after that. It's not 5 or above, so this one will therefore stay as a 2, and that's our answer to 3 significant figures. Not forgetting our unit, so this time it's current, and our unit for current is amps. Okay, question 5. The table shows some information about electrical appliances in the home. Here you can see the appliances, the power, current and resistance. We need to use the table to describe the relationship between power and resistance. So here you can see that the power values aren't in any order, so we need to be looking. Let's take our extreme examples. Let's take our lowest power here. So our lowest power of 500 has a resistance of 105.8. Again, let's take our highest power rating, which is this one here, which is 2,500, and you can see that our resistance over here is 21, which is our lowest resistance. If we check through for the rest, the next highest power resistance of 2,000 has the next lowest resistance, and again, the pattern continues. So using the table to describe the relationship between power and resistance, we're going to say that as the resistance decreases, the power increases. Again, remembering to give the headings to make it really clear that we know what we're talking about. Now we need to explain this relationship and use ideas about our resistance in our answer. Well, we know that as the resistance decreases, the current is going to increase. As current therefore increases, the power will increase, because we know that power and current are linked by the equation power equals potential difference multiplied by current. So if the potential difference is remaining constant and this gets bigger, this number here, the power, must also get bigger. The security light is switched on for 50 minutes every day for 7 days. Calculate the energy transferred in joules and give your answer in standard form. So for this question, we're going to use the equation energy transferred equals power multiplied by time. We want to work out the energy transferred, so we're going to put our numbers in. So the energy transferred equals the power multiplied by the time. The security light, I was just thinking where to get the question from. The power is over here, which is 500, multiplied by the time. Now it tells us on for 50 minutes every day for 7 days. So we want to get that in our standard units of seconds. So our time So we want to do 50, which is our time in minutes, times by 60 to give us our answer in seconds, multiplied by 7, as it's on every 7 days, which gives us 21,000 seconds. So we're going to multiply 500 by 21,000, and if we work that out, we get 10.5 million joules. We now need to give our answer in standard form. So standard form, our value needs to be between 0 and 10. So it will be 1.05. That will be where our decimal point goes, times 10 to the 1, 2, 3, 4, 5, 6, 7. I don't know why I write it so high off the line. Okay, our next question, we need to explain the difference between direct voltage and alternating voltage. So in direct voltage, it does not change, the current doesn't change direction. So it stays either at the positive or the negative. And in alternating voltage, it does change direction between plus or negative. Again, exam tip, have better handwriting than me. The mains electricity can be produced in the power station that burns coal. An electric iron is plugged into the mains and switched on. The temperature of the iron increases. Describe the process and use ideas about energy stores in your answer. So this question is linking back to the energy topic in physics. So the first thing that we'd have is a chemical store in the coal, which would be emptied, and that would eventually be transferred to the thermal store, which is the temperature of the iron increases. So the chemical store will reduce and the thermal store will increase. And the amount of energy in the process will remain constant. So the amount of energy gained by the thermal store will equal the amount of energy lost by the chemical store. Okay, getting our way through it. So, question 6. Calculate the power dissipated in the thermostat. Give your answer in milliwatts. So for this question here, we want to calculate power, and we've been given current and we've been given resistance. So we're going to use again the equation power equals current squared multiplied by resistance. Our current has been given to us in milliamps, and again we want to convert it into amps. So to do that we will divide by 1,000, as there are 1,000 milliamps into 1 amp, which gives us a current of 0.04 amps. So we know that the power equals the current squared, which is 0.04 squared, multiplied by the resistance, which is 800, and is in standard units. And if we work that out, it gives us 0.0128 watts. Now it wants us to do the answer in milliwatts. So we're going to be doing the opposite. In here, where we went from milliamps to amps, we divide by 1,000 to go from milliwatts to watts. We're going to want to multiply, my apologies. We want to go from watts to milliwatts. We're going to multiply by 1,000. So multiplying 0.0128 watts will give us 12.8 milliwatts. That's our answer. What is the resistance of the fixed resistor in the circuit? Show your workings. Okay, so in this question, we know that the potential difference will work out firstly across the thermostat, and then we can work out the potential difference across the resistor. So the potential difference across the thermostat will equal the current multiplied by the resistance. So if we work this out, the potential difference equals the current, which is 0.004, multiplied by the resistance, which is 800. And if we work those out, we get 3.2 volts. So we know that the potential difference here is 3.2 volts. We know that it's a series circuit, so we know that the the potential difference here added to the potential difference here will equal the total potential difference, which is 6. So we know that 6 equals 3.2 plus this voltage here, which I'll call X. So therefore 6 minus 3.2 will equal X, and that leaves us with 2.8 equals X. So we know this is 2.8 volts. And we want to work out the resistance. So again, we're going to use the equation that the potential difference equals the current multiplied by the resistance. So the potential difference in this case is 2.8 equals the current, which is, again, it's a series circuit, so that the current is constant. So 0.004 multiplied by the resistance. So to bring the 0.004 over here, we'll divide it. So 2.8 divided by 0.04 equals the resistance. And working out on our calculator gives us 700. And the unit of resistance is ohms. Okay, the thermostat is heated in hot water. Explain how this changes the reading on the voltmeter. Well, we know that as the temperature increases on the thermostat, the resistance decreases. So therefore, as it's heated, the resistance of the thermostat will decrease. If the resistance will decrease over here, then it will take a smaller share of the potential difference, and therefore the potential difference reading will be lower. The potential difference reading will be lower. Okay, question 7. Resistor is connected to a power supply. Potential difference across the resistor is 6 volts. Which of these corresponds to a potential difference of 6 volts? Circle the correct answer. Well, for this one, we can use the equation that potential difference equals energy transferred. Equals energy transferred divided by charge flow. We know that energy transferred is in joules and charge flow is in coulombs, so we know that potential difference is the equivalent of joules per coulomb. So therefore, the answer is this one. Okay, the resistor remains connected for a period of time. The current in the resistor is 200 milliamps. A total charge of 42 coulombs flows through the resistor. Calculate in minutes the time taken for this amount of charge to flow through the resistor. So firstly, I'm going to change my current into a standard unit of amps. So to go from milliamps to amps, we divide by 1,000. So therefore, my current is going to be 0.2 amps. We then know from the equation that time equals charge flow divided by current. So therefore time equals the charge flow, which is 42, divided by the current, which is 0.2, which equals 210. Because we're working in standard units, this is going to be seconds, and we want to work the answer out into minutes. So we need to do 210 divided by 60, which will give us 3.5 minutes. Calculate the total energy transferred by the 6-volt power supply when a charge of 42 coulombs flows through the resistor. So for this one, we're going to use the equation energy transferred equals charge flow multiplied by potential difference. So the energy transferred equals the charge flow, which is 42, multiplied by the potential difference, which is 6, which gives us 252. So our answer is 252, and as its energy, the unit is joules with a capital J. The resistor becomes warm while there is current in it. Explain why the resistor becomes warm. The resistor becomes warm because there will be collisions between the electrons of the flowing electricity and the metal ions. Therefore, the kinetic energy of the metal ions will increase as they're being hit by those collisions between the electrons. Okay, 7.5. The figure shows a cardboard tube with a wire coming out from each end. There are two 10 ohm resistors inside the cardboard tube. A potential difference of 6 volts is connected between P and Q. There's a current of 1.2 amps in the wire. Deduce how the resistors have been arranged. Now we know from this that the resistors could be arranged either like this, so they'll be in parallel inside here, or the resistors could be arranged in series. If we work out the actual resistance inside, so the resistance between P and Q will equal the potential difference, which is 6, divided by the current, which is 1.2, gives us 5 ohms. Now we can see from this, if the resistance is 5 ohms, this is less than either resistor's 2 ohms. So as 5 ohms is less than 10 ohms, we therefore know that they must be connected in parallel. We must be connected in parallel. If their resistors were connected in series, then it would be the total of the 210, which would be 20 ohms. So therefore we know it must be in parallel. Okay. A student builds a circuit using filament lamps. The figure shows the circuit with 2 identical filament lamps. Compare the currents I1, I2 and I3. So we're comparing the current here, here and here. Well, the first thing that we know is that the current comes around here, it's going to split. So we know that the current in I1 must be greater than I2 or I3. Because the bulbs are identical, we also know that I2 current will equal the same as I3. And just to ensure we get the result, we also know that the total current will equal the current in the branches. So we know that I1 will equal the same as I2 plus I3. Calculate the charge that flows through the cell in 1 minute. Each filament lamp has a power of 3 watts and a resistance of 12 ohms. Write any equations that you use and give the unit. So firstly, we're going to be trying to work out the charge flow. So the charge flow will equal the current multiplied by the time. So therefore we know that charge flow equals the current multiplied by the time. We know that the time is 1 minute, so in standard units that will be 60, but we don't know what the current is. So in this double equation question, which always comes up when there are 6 marks, we need to use something else. We've also been given power and resistance, and we know that power equals current squared multiplied by resistance. So the power is 3, which equals the current squared multiplied by the resistance, which is 12. So rearranging this, we get 0.25 equals current squared. So the square root of 0.25 will equal the current, which is 0.5. And we can then put current back into our top over here. So we know that the charge flow is the current which we worked out, which was a half, multiplied by 60, which is 30. So our answer for charge is 30, and our unit is coulombs. Okay, we've got a big 6 marker again. The student builds a different circuit as shown below. Explain how the readings on both meters change when the environmental conditions change. So let's have a look at what we've got. So here we've got an LDR. We've also got a fixed resistor over here, a voltmeter, ammeter, and our cell. So we're talking about an LDR, therefore we know it's all to do with light intensity. And we know that if the light intensity increases, then the resistance of the LDR will decrease. Therefore, because the resistance is decreased, we know that the overall resistance of the circuit will also decrease. This is because the potential difference across the circuit will stay the same, as we're not changing the cell. Potential difference will therefore decrease across the LDR, which will mean therefore that the potential difference will decrease. So the potential difference across the fixed resistor will therefore have to increase to keep the same total potential difference across the circuit. And because the total resistance of the circuit has decreased, like we said here, the ammeter reading will increase because a decreased resistance means the current will have increased. Okay, moving on to question number 9. So a student sets up the electrical circuit that is shown below. The ammeter displays a reading of 0.10 amps. Calculate the potential difference across the 45 ohm resistor. So because current is the same in the series circuit, we've got the current, we've got the resistance. So we know that the potential difference equals the current multiplied by the resistance. So we know the potential difference equals the current, which was 0.10, multiplied by the resistance, which is 45. And if we work that out, we get 4.5. Our unit for potential difference is voltage. Calculate the resistance of the resistor labelled R. So we're looking for the resistance of this one over here. So we can use the same equation, potential difference equals current times resistance. We want to rearrange to get resistance, so the potential difference divided by the current equals the resistance. We know that the potential difference is 12, which we get from here, divided by the current, which is 0.1, to give us the resistance, which is 120 ohms. So that's for the entire circuit. We then know that the total resistance of these 3 resistors in series will add up to the total. So we know that 120 equals 60 plus 45 plus X. So if we work this out, we bring these over here, we find that 15 equals X. 120 minus 60 minus 45 leaves us 15. So therefore we know the resistance of this one must be 15 ohms. State what happens to the total resistance of the circuit and the current through the circuit when switch S is closed. So when switch S is closed here, it provides an alternative route for the electricity to travel. So that will make the resistance less. So the total resistance will decrease. And therefore, because the total resistance has decreased, the current will therefore increase. And the final question, bringing us back round to the circle, you can see a very similar question here where we have to complete the circuit diagram for how a student can investigate how current varies with potential difference for 2 different lamps. So we need to complete the circuit diagram. So if we need to measure current, then we're going to need an ammeter. If we want to measure potential difference, then we're going to need a voltmeter. We're going to need a lamp as well, and we want to vary the current, so we're going to use a variable resistor to allow us to do that. So when we're drawing our circuit, we want to have our ammeter connected in series. There's our lamp that we're investigating. There's our variable resistor, and finally our voltmeter connected in parallel. Which lamp will be brighter? Any potential difference? Explain your answer and use the results to aid your explanation. So when it says use the results, what do we need to do? We need to use the results. So let's take a potential difference. Let's take a nice easy one. Let's take 3 here, because you can see the values are on the line. So if we look along for lamp B, at 3 volts, the current was 0.2 amps. For lamp A at 3 volts, we can see that it is 0.4 amps. So therefore we can see that the current in A is 2 times in B, because this is 2 times this one. Therefore, if the current is twice as much, it will be 2 times more powerful and 2 times brighter. Lamp B has the highest resistance at any potential difference. Explain how the results show this. Well, you can see here that the gradient of the line is always lower. Lamp A is always higher than lamp B. So I would say the current is always lower for B than A at any potential difference. Any point along here, it's always lower. Alternatively, I could be saying the gradient for B is lower. And then finally, both lamps behave like ohmic conductors through a range of values of potential difference. Use the results to determine the range for these lamps and explain your answer. Well, if it's an ohmic conductor, the thing that we know about an ohmic conductor is that they are directly proportional, the relationship between potential difference and current. And if it's directly proportional, then we know 2 things: that it passes through the origin, and it's a straight line. So we're looking for the points where it's a straight line and passing through the origin. So coming back to our graph, you can see that right at the start there, that's the point where it's a nice straight line. And I would say that that's between sort of 0 and 2 volts here. We sort of got a straight line. So therefore, between 0 and 2 volts. So there's our 3 marks. Between 0 and 2 volts, this is where it's directly proportional. It passes through the origin, and it's a straight line. Okay, so I think that was my longest video to date. There was a load of questions there to go through. You can check through your answers and see how to answer them. Happy sciencing!